everyone, welcome to CSCI 287 Data Structures Hands-on Practice. In this video, we will introduce single linked list implementation in Java. In particular, we will focus on how to implement the delete method in the linked list class. The purpose of the delete method is to remove a node with a specified value in a list based on the assumption that all values in the list are unique. To implement the delete method, the return of the method should be a linked list. And the input of the delete method should include a linked list and a specified integer value. In a single linked list, there are three scenarios for node deletion. That is, the deletion of head node, the deletion of middle node, and the deletion of tail node. It is worth noticing that when deleting a middle node or a tail node, we need to modify the pointer of the previous node. In a single linked list, there is no pointer to trace back, and thus it will be more efficient if we can memorize the previous node rather than search it again from the head of the list. To memorize the previous node and to access the current node, we create two node objects to store the current node and the previous node. We assign the head of the list to the current node because this is the first node in the list. Because the current node is the head, so there is no previous node, and therefore we set the previous node to null. To delete a node with the specified values, we need to traverse the linked list to identify which node holds the specified value. For this reason, we create a while loop to iteratively retrieve the value from the current node and compare the retrieved value to the user-specified value. The stop conditions of the while loop include 1. When the data stored in the current node is the same as the user-specified value. 2. When the current node.data is not the specified value, we will need to move to the next node. Or 2, when we reach the end of the list without finding the user-specified value, In this case, we will add the second condition as an if statement inside the loop. To handle this, we will display a message. The message will say the entered value cannot be found. And then we can stop the loop and return the list. After comparing the data retrieved from the current node and the searching process, we need to make the current node as the previous node to memorize it. To achieve this, we will memorize the current node as previous node. And then we take the next node as the current node. In this way, we can locate the node which holds the user-specified value and memorize the previous node. As aforementioned, that there are three scenarios when deleting a node. We need to deal with each scenario differently. Here, we introduce if, else statement to handle each scenario. The first block will handle delete a head node. The second block will handle how to delete a tail node. The third block will handle how to delete a middle node. To detect a head node, we can use the property that there is no previous node. So when we select a head node, the previous node must be null for a head node. To identify a tail node where its current node pointer should be null because it's the last one, and with the pointer is pointing to the terminator. Otherwise, the current node is the middle node. To delete the head node, we simply assign the head to the next node. To delete the tail node, we simply assign the terminator null to the pointer of previous node. To delete the middle node, we set the pointer of previous node to point to the next node. In this way, we can delete the current node, which holds the user-specified value. At this moment, we can save our Java code. We try to compile it to ensure there is no problem, and we run it to ensure there is no runtime error. Okay, so now it's good to go. For the implementation of other methods in the LinkedList class, please watch the coming video. Thank you for watching. Bye-bye.